Hi, today we'll talk about adding and subtracting with significant figures. Now, when we're adding and subtracting with significant figures, it is important that you do know the rules on how to count and round significant figures as in the previous video. So if you still are unsure of how to do that, make sure you go back and refer to the previous video and do some more practice. In any measurement, the last digit is an estimate, the uncertain digit. So when we look at this measurement right here, okay, if we're measuring this, we've got 1, 2, 3. We know that there is the 3 centimeters and it's a little bit after it. So if we were to make an estimate on this measurement, we would probably estimate this to be about 3.2 centimeters or maybe 3.3, and both would be valid measurements. We would have that estimated digit right here, right? These are our estimated digits. These are the certain digits, and the 2 and the 3 would be our estimated digit. When we are doing measurements, sometimes we need to do calculations. For the rule, when adding and subtracting measurements, the answer must have the same number of digits to the right of the decimal point as there are in the measurement that has the fewest digits to the right of the decimal point, or the leftmost uncertain digit. So let's take a look at some examples to see what this means. So example number 1, we've got 1.4 meters plus 14.32 meters plus 8.014 meters. Now when we're adding and subtracting with significant figures, it's helpful to line up the numbers by decimal. So we'll rewrite this as 1.4 meters plus 14.32 meters plus 8.014 meters. And we're adding these up. And we want to line up the decimal because the rule is it's the leftmost decimal, or the least number of decimals to the right of the decimal, or the leftmost uncertain digit. So when you add this, if we were to add this all up, we would get 23.734 meters. Now we want to look at our uncertain digit. So here is our uncertain, here are the circled ones, these are our uncertain digits. And so the rule is it would be the leftmost uncertain digit. And so that would be lining up right down this way. So this would be our leftmost uncertain digit. So rounded to the correct number of significant figures, it would be 23.7 meters, and this would be our answer. Let's look at another example. 86.35 liters minus 9.1 liters. So same thing, you want to line up your numbers. We have 86.35 liters minus 9.1 liters. Now look at your uncertain digits. These are our uncertain digits. So when you calculate the answer, we get 77.25 liters. Now we always want the leftmost uncertain digit, so that would be this one right here. And so we would round it, and this would round to 77.3 liters. And that's our final answer. One more example. 2500.34 milliliters plus 130 milliliters plus 12 milliliters. Again, we line up our decimals. $130 milliliters and 12 milliliters. Now remember, when we look at these numbers, even though the bottom two numbers don't have decimals, we still have a leftmost uncertain digit. So here are my leftmost uncertain digits. And so if I add these up, I get 2, 6, 642.34 milliliters. Now we look at our uncertain digits, and my leftmost would be this one right here. So if I'm writing the answer out, I would have 264. But I can't leave it like that because my answer was 2,642.34, and 264 would be incorrect because I'm missing the value. So I would put a 0 as my placeholder, but it's not significant, and so I still have the correct number of significant figures and the value. So the answer for this one would be 2,640 milliliters. Now go into your packet and do some of the quick practice problems. Thanks.